everybody, welcome to another video. Hope you're ready to flex those brain muscles because today we're talking about multiplying fractions. And multiplying fractions is actually pretty simple. It's the easiest operation to do with fractions. It's easier than dividing. It's definitely easier than adding and subtracting. So let's go ahead and do a real quick explanation. We're going to use some example problems to look at how to do this. And yeah, so multiplying fractions, our first example, 4 over 5 times 1 over 2. Or 4/5 times 1/2, however you want to say it. Right, so what do we really have here? And I drew a little picture so we can kind of see what's going on. And I drew this and I divided it into 5 pieces. So each one of these little blocks is 1/5. So what do we have? We have 4/5. And when we multiply by 1/2, that means 1/2 of 4/5. We're taking 1/2 of 4/5. So we're left with whatever half of this is, right? So if we have 4/5, that's 4 of these. 1, 2, 3, 4. So 4 out of these 5 blocks, right? 4/5, 4 out of 5. And now we're taking 1/2 of this. That's what happens when we multiply something by 2. 1/2. So we're going down from 4 of these blocks to 2. 1, 2. So what do we expect our answer to be from this? We expect our answer to be 1, 2 out of 5. 2 of these blocks out of 5. 2/5, right? So let's see how we can get there. And this is the process for multiplying fractions. You just simply multiply the numerator across and you multiply the denominator across and then you simplify. It's that simple. So we'll go ahead and do it. Let's see. So 4 times 1. 4 times 1, that's what's on top, and then 5 times 2 is on bottom, right? I just combine them, I multiply across, that gives us 4 over 10, and that actually simplifies to 2/5. What you do is you divide the top and the bottom by 2, right? So I can divide the top and the bottom by 2, and it simplifies into 2/5. 4 divided by 2 is 2, 10 divided by 2 is 5, and there we go. That's how we multiply fractions. Multiply across, simplify. Very simple. So we'll do a few more examples. We'll run through it real quick. 3/16 times 2/3. So we have 3/16 and we're taking 2/3 of that. So we expect this to be smaller than 3/16, right? It's pretty clear to see that. If we're taking 2/3 of something, that's less than the whole 3/16. So we're taking 2/3 of this. So it's going to be, right? So keep that in mind. So let's go and write out the process. Numerator, multiply across, 3 times 2 over denominator, 16 times 3. And here's why it is an advantage to write this intermediate step out, because some people would go straight to, they would write 6 over 48, and then they would simplify. But there is a little bit of an advantage of this, and that's because you could do stuff like this. You could cross out these 3's. 3 over 3 is 1. There's all multiplication here on the top and the bottom, so you can just cross stuff out. So 3 over 3 is 1. 2 over 16, what does that equal to? 1 over 8, right? So it does sometimes help to write these as just products, and maybe you can see it in that initial step, and you can just look at it and just immediately cancel these. And if you could do that, then that's awesome. Good for you. So let's look at this example. So in this case, we have an improper fraction, which means it's a fraction that's greater than 1. And that's why I gave this example, just to see how is it different with an improper fraction. And the answer to that is it's not different at all. It's still the exact same process. We're going to multiply the top across and then multiply the bottom. So 7 times 1 is going to give us 7. And that's over 5 times 2, 10. Can we simplify this? No, right? So it's that simple. Even with an improper fraction, you just multiply across like that. So we'll do a couple more examples. Okay, let's look at this example where we have a whole number times a fraction and see how it's different. It's a little bit different. So we said the first step was that we multiply across the top and the bottom, and then we simplify. That's how we multiply fractions. But technically there's a step before that first step. And the very first step is you have to set these up as 2 fractions. That's how you can multiply the top and the bottom across. This doesn't have a top and the bottom yet, right? And that's how we kind of modify the whole number. So let's think about what a whole number is. Any whole number is still a rational number because it can still be expressed as a fraction, because any whole number is just that number over 1. So when we have 5, we can just rewrite it as 5 over 1. And it's a fraction, and then we can multiply. So that's exactly what we do. We write 5 over 1. 5 over 1 times 2/3. And then we just multiply across. And now it's just like we've seen in the examples before. So we're left with 10 over 3. And now I'm going to introduce what we call mixed numbers. Is that this can be left as 10 over 3, and this is improper fraction, but this is equivalent to 3 and 1/3, right? And this is called a mixed number because we have a whole number and a fraction. And what this really means, 3 and 1/3, that means plus. So what we really have is 3 plus 1/3, right? And how we got this 3 plus 1/3 from 10 over 3 is that 3 is just 9 over 3 plus 1/3, right? And this gives us that 10/3. 3 is just 9 over 3. I'm just putting it over 3. I'm basically multiplying 3 over 1 by 3 over 3. So that's how I'm getting from here to here. But this is just something worth noting, that mixed numbers, because we'll get to that in this example. And in fact, let's go ahead and skip to this example real quick now that we've seen that. So 3 and 1/2 times 1/4. How do we evaluate this? And it's a little bit trickier. Again, you have to do that step before the step, which is that step before the first step. Write this as a fraction, right? So we have to express this as a fraction because right now it's not. What did we say? We said 3 and 1/2. We said that's like writing 3 plus 1/2, right? But this whole thing is being multiplied by 1/4. So we have to rewrite this as a fraction, and we use this exact same process where it's that process of adding fractions where we find a common denominator. And if you don't know what that means, then I have another video on it you can click on. But we have to find a common denominator so we can add these. And it looks like this is 3 over 1. This is 1 over 2. It looks like the common denominator is going to be 2. That's going to be the least common denominator. And we can get that by just multiplying this to be 2 over 2. So let's do a little side work here. If we multiply 3 over 1 times 2 over 2, I get 6 over 2, right? You see how that's still equal to 3? And then I just add that 1/2 and I get 7 over 2. So this whole thing in the parentheses is equal to 7 over 2, right? So I can rewrite this as 7 over 2. And now what I'm left with is 7 over 2 times 1 over 4. And now I've finished that step before the first step where I've set this up as a fraction, and now I can just multiply across. Right, so yeah, that's how you work with the mixed numbers. You just have to rewrite it. 3 and 1/2, whatever it is, 3 and whatever it is, the whole number and the fraction, you just add them, and you use the process of adding fractions to find a common denominator and that sort of thing. So let's look at this last example. It's the same example of what we've seen before, but this time it's just 3 fractions being multiplied. And it's literally the exact same thing. You multiply this times this times this over this times this times this. That's all the tops over all the bottoms, right? And that's exactly what you do. It doesn't matter how many of these fractions there are. There can be 20 of them. It's just going to be everything on top multiplied together, all over everything on bottom multiplied together every single time. So 2 times 1 times 5. Let's see, that's going to give us, well, actually, what we can go ahead and do is, well, write in this step, 2 times 5. We can see how the 2's are going to cancel, right? 3 times 2 times 3. Sorry, this is getting a little messy. 2's cancel. And now I'm left with, what am I left with? 3 times 3, that's 9. And the 5's on top. 5 over 9. You see how I canceled those 2's? So same process when you multiply 3 fractions together. So yeah, this is just a quick explanation, just a refresher, a recap. Hopefully a lot of this looks familiar on how to multiply fractions. We do use this when we do rational expressions, and throughout calculus you need to know how to do this. So it's good to practice and kind of go back and make sure you got this stuff down. If you need to see more examples, let me know. If there's a demand for it, I'll make another video with a bunch of more examples. But yeah, for now, that's it for the video. Go ahead and leave comments and questions below. Hit subscribe if you enjoyed. Hit the like button, that sort of thing, if you want to support me. And yeah, keep flexing those brain muscles. Keep making those brain gains. See you later.